have been working on web performance for the last 2 decades almost, in a few months. So that means 2 things. One is that I'm old, but the other is that I have invested basically, I invested my whole career on the assumption that faster is better. And I feel pretty good about that because we have a lot of case studies that show that various metrics of user satisfaction and business metrics go along with that, and faster sites get better results. At the same time, after 2 decades, we still don't know to define what is fast. In the early days, we used to have, or we still have, window.onload as the metric that people look at. But its relevance has declined over the years because it doesn't really correlate with the user's experience today. For some websites, window onload fires way too early before anything is on screen. For others, it fires significantly later than when users would consider the site usable. But window.onload has many pros that make it very hard for us to get people to stop using it as the metric. It is simple to define and understand. Just wait until all the site's resources finish loading and then you're done. It's ubiquitous. It's supported in all browsers. And it, most importantly, at least in my view, it doesn't require any extra work from the developer to define what the metric means in order for people to be able to measure it. And we've been telling people that they should move on for the longest while, I would say around 10 years. But we didn't really provide them with a good alternative that has all those qualities, all those benefits. We tried to get people to move on to user timing and define their own custom metrics. But user timing can only measure things that are happening inside JavaScript. And at the same time, it requires a lot of work. And people are not necessarily, the people who are measuring performance are not necessarily the people who will do the work and know the content well enough in order to do the work and define what is the custom metric for each different part of their sites. And on top of that, we've also came to the realization that there is no single metric that will represent the entire user journey. So we need various metrics. We need multiple metrics that will represent meaningful points in the user's journey. And we need them to define, to provide that by default. But at the same time, we need those metrics to be customizable. And we need, for the cases where developers are willing to invest extra work in making the metrics matter more for their site, that needs to be possible. There are also various different categories for our various performance metrics. So traditionally, we focused on onload and DOM content loaded, which are not really related to what the user is experiencing. Both are related to what the browser is experiencing when the page is loaded. But when we look at what the user is experiencing, we have visual metrics on the one hand. So when is the website being rendered on screen? What is the user seeing? We have interactivity metrics. So is the website slow to interact with? If the user clicks on something, is that janky or is that smooth? And then finally, we have user annoyance metrics, for lack of a better term, and we'll talk about that in the end, but it's basically, for right now, focusing on bad patterns that happen during page load. Um, we also have RUM measurements, so real user measurements versus lab. And I'm not going to go into the debate of which one is better because there is no better. RUM is great in order to get real-life results from users in the wild on real-life devices in scenarios you didn't really think of testing, and in conditions you didn't think of testing. At the same time, lab testing gives you a very predictable way to recreate your and test with predictable conditions your website's performance, which gives you a way to test improvements and gives you a way to test whether you have regressed or improved over time. So starting off by talking about visual metrics. When it comes to lab, we have speed index and visually complete. Both are valid lab metrics. Both try to estimate when everything is rendered as far as the user is concerned. Both suffer from various problems when it comes to websites that continue to change, that infinitely change. So for example, when you have image galleries or pop-ups or splash screens, those are things that impact speed index and visually complete scores, sometimes to a degree that is not justified. But when it comes to RUM metrics, we added a year ago, I believe, first paint and first Contentful paint to the list of visual metrics that we didn't have before. So those metrics look at paint operations that the browser is performing and then measure the first ones. So first paint is the point in time where something that is not a blank screen is drawn on the page. But first Contentful paint is a bit more complete than that, where Contentful is everything that is a non-white, non-white canvas or any kind of text or any kind of image, including background images. And that is the point in time where first Contentful paint or FCP is registered. At the same time, it's not necessarily the most meaningful paint that the user is experiencing. This is just film strip screenshot I took this afternoon just on the first random site that I went to, which was Chrome Dev Summit. And we see that first Contentful paint here happens, right here it really looks like a blank screen. On laptop you can see that there are some very small gray gradients, but at the same time, from a user's perspective, it's indistinguishable from a blank screen, and even if it wasn't, it's not necessarily something that the user can do anything with. And we also have the first meaningful paint metric as part of Lighthouse, but that was never standardized and never attempted to bring it over to other browsers and other rendering engines out like beyond Chromium and Blink, because it's very much based on Blink implementation details and various heuristics that are hard to reason about. So it's still a metric as part of Lighthouse, but it's not something that we're trying to standardize and bring over to be a web-based metric, a RUM metric. And the replacement for that, or the next generation of that effort, is largest contentful paint. Where contentful here mean very much, like it's very similar to the definitions that are part of the first contentful paint. But here we're trying to capture the largest one, basically relying on the assumption that the largest paint operation or the largest element on the page is likely to be, even if not the most meaningful one of the most meaningful ones. So the impacted elements, similar to FCP, are HTML images, background images, various text blocks. And as part of the entry, you can see either the render time for either the text or the image, or the load time in cases where we cannot really expose the render time due to lack of CORS permissions for cross-origin images, as well as the size, the area of the image, the element's ID, the URL if it's an image, and a link to the element itself in case the element is still attached to the DOM. And each entry that is emitted by the browser is the largest entry so far, because the browser cannot really predict the future and cannot know ahead of time what would be the largest one. So as developers, you are probably interested in the latest one, or at the same time, you can look at all the different, looking at all the different largest elements throughout the page loading gives you some sense of the journey, gives you a way to recreate some sort of a film strip. Simon, if you can get on something that visualizes a film strip from RUM based on all the largest entries so far, that would be awesome by the end of the evening, if possible.
Done.
Cool. And then we talked about the metrics customizability. So the assumption that largest is the most meaningful one is not always the right assumption. And for that, we have element timing. So whenever developers are interested in making that metric more precise or getting more measurements from their page regarding other elements that are not necessarily the largest, they can add a markup attribute of element timing to either basically any random element that is rendered. I mean, adding that to a script won't make a lot of sense, but any block level element or even inline one, I think, will work. And yeah, for images it works. So that would give you very similar entries for that specific element that also include everything we talked about before, but also the identifier, which is the value of the element timing attribute. So you can know which element that was without having to necessarily look at the element node itself. So that, if you're interested in measuring visual metrics and visual metrics of your site loading, that should give you, between LCP, which is there by default, and element timing, which is there if you want it, if you want to make it more precise, that should give you more or less a complete picture. And yeah, I don't have a slide for that, but basically as far as browser support right now, so LCP is just, as well as element timing, are just shipping in Chrome 77. So the next version that will make it into stable, it's now in Chrome beta, where first paint and first Contentful paint have been shipping for a while in Chrome, but not yet in other rendering engines. Okay, interactivity metrics. Who here is familiar with TTI or time to interactive? Who here likes TTI? Hey, Simon, and yeah, sure. Thank you. But most people don't really get TTI and don't really don't necessarily agree with the fact that it represents the user's experience, and it's very hard to argue with that. TTI has many arbitrary values. You have to wait for a period of time of the browser being idle before retroactively declaring that TTI happened before that. And it's essentially a lab metric because it's hard to reason about TTI for pages that actually get interacted with. When it comes to RUM, we have long tasks that are the underlying primitive behind TTI. So they enable interested folks to calculate TTI as part of a RUM metric, and they generally enable people to know when the browser's main thread was fully occupied, or fully occupied for a long period of time, where long is defined as anything over 50 milliseconds. So they can enable you to know when the main thread was pinned down and wasn't able to handle anything else, including user interaction. And those are the points in time where if the user has interacted with a page, they would get frustrated. They would, like, the page wouldn't have responded to them as they would like. One big component that is missing from current long tasks is attribution. So you can know when those points in time happened, but you can't really do anything about it because you don't know which part of your script or your multiple scripts, potentially coming from multiple different vendors and hosts, was responsible for that particular long task. So it's very hard to, it's very hard to do the forensics work to track down blame for long tasks today. But this is something that we've heard from the web performance community as part of the web performance working group, and is probably something that we should improve, hopefully soon. But as an improvement to long tasks, or as sugar on top of long tasks, we now equally shipping first input delay, not yet event timing. Event timing is coming soon. But those are event performance entries that represent the time it took for an event to be processed. So for first input delay, all first input events will be reported as an entry, assuming that it is observed. So you can know for your users whether their first interaction with the page was a positive one or a negative one. And for other event timing entries, they will only be reported if the event took longer than a certain threshold, which is, again, I believe 52 milliseconds, because it needed to be fuzzed to some extent. But it's, in the median, it shouldn't take more than, substantially more than 50 milliseconds for users to handle, for the browser to handle user events. And in case it did, this will be reported, and each one of these entries can be considered as, okay, this was a bad user experience, and it's something that we need to tackle. And as far as attribution goes, we will still probably need to rely on long task attribution to be fixed in order to know which long task resulted in the event being long, or we would also potentially, we'll need to figure out attribution for event timing. This is not part of the currently shipping solution, but it will be potentially in the future. And as for TTI, despite the fact that Simon and Andrew like it, there are many people who feel that it is not a sufficient lab metric in order to measure interactivity issues. So there's a new metric in the works called total blocking time, which is the sum of all queuing times that are longer than 50 milliseconds. And various tests have shown that it gives a better, it correlates better with actual interactivity problems as well as sites that don't really have interactivity problems compared to TTI. And you can also implement it yourself with long tasks by just summing up the duration of all of them while deducing the 50 milliseconds at start. And finally, user annoyance. That's the final and relatively new category that we're considering. And in order to explain, can you click the video thing? So just so this is the problem. So this is something that we haven't really looked at before, but getting feedback from users, it's really becoming a real problem on the mobile web, especially with loading of ads, as in this case, or loading of images, where the website's layout moves around, making it very difficult to click on the right thing, or even to read, because the point in the article, like you start reading the article, and then some resource above where you are loads, and that pushes down everything, and it makes it hard for you to track down where you are in the article. So we are introducing a new metric to measure that problem, because at the WebPerf working group, we believe that you can't really fix what you can't measure. So the layout instability API will enable us to measure that issue, measure those layout shift scores, where it defines a layout shift as the surface area of the fraction of the viewport that is moving times the distance that it moved also as a fraction from either the viewport height or the viewport width, which is a bit complex, but it basically means that this piece of the viewport moved by that portion of the viewport, and a score, like the ideal score here would be 0, where nothing has moved. Once it has been laid out, nothing has actually moved. That is very hard to attain, but the desired score should be as close to 0 as possible. And 1 means that the content has moved by an entire viewport. So the content of the full viewport moved by 1 viewport down, if that makes more intuitive sense. So we have new performance entries to that effect that give us the value, which is the layout score, whether there was a recent input event before that layout shift event happened. So if the user clicked on something and as a result of that, things moved around, that's probably normal and expected. But if there was no input, that's less normal. We are also talking about cumulative layout shifts. So calculating the sum of all layout shifts during the lifetime of the website to calculate a final score of how annoying of an experience that was for the user. And to sum up all of these, my colleague Phil Walton joke tweeted that, but that's actually not a bad, not a bad summary. So we have for RUM, we have first Contentful paint, largest Contentful paint, cumulative layout score, and first input delay. Where for lab we have all those, like those other than first input delay, because we don't really have event times in the lab unless we script that or something. But we do have total blocking time and TTI to account for interactivity in the lab. And a couple of things that we are planning to work on in the future. One is frame timing. As part of a recent web performance working group face-to-face, we heard multiple people that are interested in reviving an older spec that measures paint performance and basically measures slow to paint frames. So this is something we're looking at and collecting use cases for. And if you're interested in that, please let me know there, because there's ongoing, very early stage discussions happening on that right now. And the second is SPA metrics. So I talked about a lot of first something something metrics, but for single page apps, the first loading of the site is not the only navigation, at least from the user's perspective. There are many other soft navigations happening. And right now, the web platform doesn't have any way to account for that, either when it comes to metrics or when it comes to terminating network requests. So the browser is loading one page and then the user clicks on something and we need to load a different page. From the browser's perspective, this is a single page, and the network requests that have started continue to drain the user's battery and bandwidth, even though they are no longer relevant, potentially. So there are various things to figure out when it comes to single page apps and how we want the browser to know what soft navigations are and what it should do in those cases. So again, if you're at all interested in that effort and providing input to influence its direction, please talk to me afterwards. And with that, I will say thank you.